Okay, so here are the topics we're going to cover in our last of the series for Beginners OSPF. We're going to cover troubleshooting OSPF, the different show commands that we have, the different debugs. I know that we did some of the debugs before, but we'll cover a bit more. And we'll cover redistribution, that is taking a routing protocol outside of OSPF and popping it into OSPF. Now redistribution, I don't think they hit you that tough in CCNA, but you will get a lot of it inside of CCNP. And also, of course, if you're going for CCIE, you're going to get killed with redistribution. In fact, that's the one thing that can completely destroy your network is you redistribute wrong and you have loops and all that type of stuff. And then you figure out you're confused why you did the lab and you scored like a 40% or something. So redistribution becomes a more serious topic as you get more deeper into your Cisco studies. So you shouldn't have any OSPF running. You should be completely bare. And so just check that. Show IP protocols. Just make sure that is blank. Another thing you could have done for OSPF just to see if it's running is I believe you could try ping 224005. And if you get a reply back, that means someone out there is listening. So 224005 and 224006, those are the two OSPF IP addresses. So we'll actually do that ping address later on with OSPF running just to see if we get a response back. So yeah, Mark already typed that in. So let's figure out what we want to do with OSPF here. That's our topology. And let's do the typical, we're going to throw area 0 into here. Actually, you know what? Let's not do that. Let's try something different. Let's start area 0 on the left-hand side. So something like that. So area 0 is going to be R2, R1, and the left-hand side of R3. So let me show interfaces here. Yeah, we'll draw a circle just for visual reference for you guys. Right, so that's going to be area 0. So let's get that set up. So on R2 and R1, you know that life is pretty easy. You could pretty much just do the Hail Mary, network all zeros command. So R2 and R1, area 0. Okay, so you throw R1 and R2 into OSPF, and you got a little delay, and that's because your interface is waiting for that dead period, that dead interval, the 40 seconds, just to see if other interfaces are wanting to be the DR and BDR. So that's the whole DR BDR election. And you can see that with show IP OSPF interface brief, you got two interfaces that are in the wait state right there. And after that, you see your OSPF adjacency come up. And our neighbor is 99.99.991, and that's one of the loopback addresses on the other side. So we probably should have done our router ID command. And actually, let's do that. Let's go on R2, router OSPF1. Let's change the router ID to 000.2. Clear IP OSPF process. And do the same thing over on router 1. Just do a router ID of 0001. Right, so the neighbors are going to go down when you reset the OSPF process, clear IP OSPF process. You see it goes through this whole 40-second deal again because you've basically kicked it over. And any day now, that interface should come up. There you go. And you can see the neighbor, it says 0002, so I know it's router 2. Just makes my life a lot easier. And of course, show IP OSPF database. Things look a lot nicer on those router link states. 0001, router 1, 0002, router 2. Okay, and let's try that ping multicast address, 224.0.0.5. Right, so you get responses back when you ping that multicast address, 224.0.0.5, 224.0.0.6. So that is alternative to doing the show IP protocols. What if you wanted to find, if you had Eigrp neighbors, what address might you want to ping? Two two four zero zero 10, correct. Okay, so R1 and R2 are good. We're going to configure the left half of R3, so it's fast 00, fast 00. So who remembers how to do that just on the interface, so without a network command? So go into the interface and type in IP OSPF 1 area 0. Right? And that's just putting that interface into area 0. Who here has worked or will work on the Nexus, Cisco Nexus, let's say the 5000 or the 7000? Anyone? Both? Okay, so you know that on the Nexus, when you're setting up OSPF, you can only do it on the interface. There's other stuff that the Nexus will do, like you can finally do slashes. You don't need to do the type in do, so show run. And also another thing I like about the Nexus is it's no longer Ethernet, interface 10, 10 Ethernet or gig Ethernet or all that stuff. It's just Ethernet. Okay, now that we have area 0 pretty much good, we can go on R2 and just check things out, like show IP OSPF database, right? You could show that. So in your router link states, you should be able to see 0001, 2, and 3. Life is easy. Under network link states, you got 2, 12.2, and 13.1, and that's because you've got 2 links that have a DR and BDR election, not a big deal. We know that we could filter out this stuff, show IP OSPF database, you could do router, right? It's going to give you kind of an ugly looking thing right there. It gives you more detailed information. If you hit the up arrow, do a pipe I and do link state, it's going to filter out just the link state IDs. So always try to do that. Always try to put pipe I for your show commands. You want to get into a good habit now because you don't want to break that habit when you're going for CCIE. CCIE, you want to be able to do all this to the T. Okay, so we got area 0 all good. Now we're going to configure area 1. So let's draw a little circle here. All right, it's kind of a pain in the ass to resize icons inside of a VM. It doesn't grab correctly. Okay, so in R3 we're going to continue. We're going to put fast01 and fast10 into area 1. So this is all area 1. So we don't need to do a router ID on that. We already did it. So IP OSPF, it's process 1 and area 1. Don't let your muscle memory kill you by putting a 0 in there. Okay, so without looking, as soon as you pop those two interfaces into area 1, what should have appeared in the OSPF database on routers 2 and 1? What type of LSAs should have popped onto the two routers R2 and R1? LSA type 3, summary LSA. That's how you get to the outside, the other areas, inter area. So let's go over to R2 just to check. Show IP OSPF database, and this is called a summary. Yeah, we got two of them. And of course we could do a pipe I, show IP OSPF database, summary, pipe I, the word link state. Very useful command. So we're seeing 34 and 35. That's from R3 to R4 and from R3 to R5. So that makes complete sense. If you don't see a summary network link state, you're not going to go to another area. Oh, we'll also cover virtual links today. Kind of by accident, but we'll take it. Okay, so R3 is good. R4 is easy. Just throw everything into area 1. You guys know how to do that. Right, after you throw it into area 1, just go back to R2, hit the up arrow, get that show IP OSPF database, pipe I link state, and you'll see you have some more stuff. In fact, if you have all the loopbacks in there, it'll give you all the loopbacks, all the hundreds. If you don't see the hundreds, don't worry about it. I'm running a slightly different config than the rest of you, but you should at least see 45, 10, 10, 45. Yeah, I'm looking at Jerry's screen. Looks like Jerry's kicking ass. Okay, he's keeping up. That's good. Okay, let's take a look at our last piece of the puzzle for area 1, looking on R5. So R5, I've got 2 links, 0, 1, and 0, 0. So pop that into area 1, 0, 0, and 0, 1. Oh, we forgot to do our router ID thing on router 4, but that's fine. We'll leave it for now. All right, so now if you go back over to R2, hit the up arrow, show IP OSPF database summary, pipe I link state. You should see, let's see what we got here. Did R5 get anything to us? Doesn't look like it, but let's show IP OSPF database. Ah, interesting. Don't think I got anything from R5, but we know we have an OSP adjacency. We are adjacent with router 3 and we're adjacent with the router 4. Let's take a look at what we have set up for IP addresses on R5. Yeah, so all I did was throw those two links into OSPF, and they were already connected to R3 and R4. They're already advertised as links, so nothing really happened when I threw R5's links into OSPF. But what I'm going to do now is I'm going to put that loop back into OSPF. So let's think about this for a second. If I start OSPF on that loopback, on R5's loopback, if I go over to R2, what extra entry am I going to get on the bottom? Who can tell me, type in the chat window, what you think that's going to look like? You kind of have a big hint just by looking at these. It's going to be a type 3 summary, yeah. And what is it going to look like? Well, you have a big hint here with this one. You think it's going to look like that one, except all 4s is going to be all 5s? Yep, I think so. So let's go on R5, conf t, interface loopback 0, IP OSPF 1, area 1. Go back over here, show IP OSPF. Might take a couple seconds. Yep, there we go. So knowing exactly how your database is going to look like after you turn an interface up or after you turn a router on, this is very, very important. This is beyond CCNA. You need this, especially if you're going for CCIE. You should be able to predict everything. A lot of people, when they start their CCNA, they just type in commands and it's like, I don't know exactly what is going to happen when I type this in. But I want you guys to practice this enough to where you know exactly what's going to show up when you hit enter or before you hit enter. Okay, so we got all of area 1 done. So I'm going to ask you guys a question. We're going to put area 2 here. What's going to be the problem with area 2 over here? It's not connected to area 0, so we have area 1 in between. So not connected to area 0, why is that a big deal? Yeah, we're going to need a virtual link. It has to touch area 0, but why? Why does it have to touch area 0? Give you a big hint. What's that guy called? That's an ABR. ABR, and why is it called an ABR? It's between area 0 and something else. If it's connecting area 0 with area 1, area 2, or whatever, it's called an ABR. Trick question. What's R5? R5 is nothing. R5 is just a router that has area 1 and area 2. If you're not connected to area 0, you can't be called an ABR. ABR only counts if you're connected to area 0. Now, when we put a virtual link there, it pretty much turns it into an ABR because it takes area 0 and stretches it all the way over to R5. But for now, it's nothing. ASBR, Mark typed it in there, ASBR means that you're between OSPF and Eigrp, or OSPF and BGP. It's a completely different protocol out there. Here it's still OSPF, but this is not going to work because we got area 1 and area 2. So let's go on fast10. We'll put fast10 on R5. We'll put it into area 2. Right, so we've got that in area 2, and you can verify that if you go back to R2, you show IP OSPF database. We're looking for 10.10.50 something, 10.10.56. And I don't see a 10.10.56 anywhere in here. Okay, and now it's easy. We go to 6 and 7 and just throw everything into OSPF. And that's going to be area 2. Keep forgetting my router IDs, but that's okay. So you've thrown R6 and R7 into area 2. And you can show IP OSPF database over here on area 2. Not much, right? It's still waiting for that 40 seconds to time out on that fast Ethernet link. That was why I was kind of scared when I show IP OSPF database on R7. I was only getting this one line. Okay, now we're okay. So we're seeing routers 5, router 6, and router 7 in area 2. We have nothing else. And that's because only ABRs can send us those summary states. Right, so that's the important thing to remember. So yes, for CCNA, it's okay to remember, okay, it just has to be connected to area 0, right? That's CCNA. You could also, CCNP, you get away with that too. But if you're going for CCIE, that's the wrong way of thinking it. You have to be connected to area 0 because only ABRs give you those summary network link states, those type 3s. And that's what gets you outside of the area. Okay, so you guys already talked about it. We probably need a virtual link. So we're going to be doing a virtual link. We're going to be stretching our area 0 from here to there. And as soon as you stretch that area 0 across, you're going to see routes start popping into R6 and R7. So first order business, let's start a debug on R7, just so we can see this live. So debug IP routing. We're going to go on R3, show IP OSPF. Let's see. Okay, show IP OSPF pipe ID. Okay, so that gives us our router ID. Go on R5, show IP OSPF pipe ID, and his ID is 0005. Now the reason I'm doing this is because the virtual links are going to be connected to the router IDs. So you're not actually sending it towards the actual interface. You're going to be doing this command towards the router ID of the other router. So just to show you what I mean, if we go back to R3, so conf t, you're going to go into OSPF, so router OSPF 1, and you're stretching this across area 1. You're throwing the virtual link over area 1. So it's going to be area 1 virtual link, and then the IP address, the router ID of the other guy. So let's see if this works. 0005. Right, you hit enter, and now it's going to be screaming some things at you. Let's take a look at R5. Oh, nothing yet. Okay, let's go over to R5 and do the virtual link going back. So conf t, router OSPF 1, area 1, virtual link 0003. All right, so you can see that kind of funny, we didn't get any error messages, but oh well. So as soon as I did area 1 virtual link, pointed to router ID for router 3, neighbor 0003 came up, VL0, that's a virtual link from loading to full. So it stretched it across. If you look over at R7, you can see, because you have the debug on, you just got a whole bunch of crap. So you start to get the summary network link states, and all of these routes came in, and we can verify that. Show IP OSPF database, summary, pipe I, link, state. And look at all that. All of this that you see here, this matches your routing table. So let me show you. So you got a type 3 for 100, 100, 0, 1. If you scroll up here to your debug, you got a route added to your routing table, 100, 100, 0, 1. Okay, that was weird. Can everyone hear me? Okay, like Google likes to kick me out for some reason. We also have a blue coat proxy here that gives us some fun. Hate those things. Okay, so hopefully you guys heard me when that 100, 100, 0, 1, you got it as a type 3 LSA, and then you've got this in your routing table. So pretty easy stuff. Virtual link is actually pretty easy. And I want you to see something here. If I show IP OSPF database, you'll see that the advertising router is going to be router 5. He's the guy that's in between area 1 and area 2. Now if we go on router 5 and show IP OSPF database, you'll see this entry here, DNA. Right, lots of stuff, DNA. Now what the heck does that mean? What DNA means is you got this through the virtual link, and in OSPF normally we wait about 60 minutes. If you don't hear anything in 60 minutes, then OSPF is going to consider the guy down. Now normally what happens is when it hits the 30-minute mark, it's going to send, a router is going to resend the LSAs. What the DNA says is to don't resend, don't do anything. This thing lives forever. Right, so DNA stands for do not age. And I think we can, if I show IP OSPF, let's see what we got here. Let's take a look at some of our timers. 5,000 milliseconds, 10,000 milliseconds. Trying to find that 30-minute mark. Oh, not there. There's got to be a show command that will show it. Yeah, I'll find it later. Oh, let's take a look at Google. Let's see what the wonderful Google will tell us. Yeah, everyone's pointing me to show IP OSPF database. That just shows the total time that that guy has been alive. All right, we won't worry about it, but just remember that DNA stands for do not age. Let's look at things back on area 0 from R2's perspective. He's all the way on the left. And if I show IP route OSPF, pipe I and O, these are all the OSPF routes. Right? They're all coming from router 1. Okay. So let's go all the way back over to R7. He's at the very right. Show IP OSPF interface brief. What interfaces are we chucking into OSPF? Oh, look, we've got a loop back here. 200, 0, 0, or 200, 111. So let's go back to R2. Let's see if we can ping 200, 111. And we can. We can ping 200, 111, show IP route 200, 111. It's telling us that we know it through OSPF, right there. It tells us the distance, the administrative distance is 110. That's kind of the standard for OSPF. It's telling us the type is inter-area. It's in a different area. Metric of 6. Well, let's take a look here. Fast Ethernet by default is a metric of 1. Let's count this out. That's 1. That's 2. That's 3. That's 4. That's 5. And the loopback is another interface. That's 6. Makes complete sense to me. So metric is 6. Do you think I can change that number if I go on any of these interfaces? If I go on any one of these interfaces and I change the OSPF cost, will I be able to change that 6 to something else? Actually, I can't go on every interface. There's one trick to that question. But if I were to go to this interface right here between 6 and 7, so if I go on R6 and I change the cost of fast01 to something else, can I change that 6 to, let's say, a 10? What do you guys think? Yes, no, maybe so? Type in the chat window your answer. Right now the metric is 6 going from R2 to that loopback. Yes, we can. We can change that 6 to anything we want. Well, not anything, but within reason. So watch what's going to happen. So R2, show IP route 200.1.1.1, I see a metric of 6. With some typing, I'm going to come back here, and when I do the show IP route again, I'm going to see instead of a 6, it's going to be a 10. And to do that, we're going to go over to 6 to 7. So interface fast01 on R6. Go to R6. Interface fast01. We're going to change the cost, IP OSPF cost. And so let's think about this. That link is now a 1. I want to add 4 to it. So what do you think my cost is going to be? So now it's a 1. I want to add 4, probably a 5. So put a 5 there. You go back to R2. Wait a couple seconds. Hit the up arrow, show IP route 200.1.1.1. You have a 10. So the difference between CCIE and CCNA and CCNP, CCNA, CCNP, you weren't sure. CCIE, you're absolutely sure, and you can type it in right away, not a problem. Almost as if you don't need to go back and check. Okay. Slightly different question. What if I tried to change the cost on this link? What would happen if I put the cost on this link to 3, let's say? Traffic would go via R4. Yeah, because we got this as 1 and that is 1. It's going to make this more expensive, so it's going to reroute over R4. And we should test this out just to be 100% sure. So let's do a trace route from R2. So we trace 200.1.1.1. So it goes router 1, router 3, router 5, 6, and 7. Right? So we're doing this on R3 fast 10. So interface fast10, IP OSPF cost. So the cost is 1 right now. Let's add, just for kicks, let's add 5 to it. So if we add 5 to it, go back to R2. Now we do a trace route. Okay, now if you see that you're getting these H's and you're hitting the same router twice, that means your network is still converging. All your routers in the middle and on the sides, they're freaking out because the cost has changed. Everything's figuring out the best path again. And let's take a look. Trace 200, 111. You're hitting router 1, that's good. You're hitting router 3, that's good. You have to hit router 3. And now it's going to 4, 5, 6, 7. So it has routed around that area, or routed around that link. All right, very useful, quick and easy way of diverting traffic away from a link. If you work for an ISP, you probably do this a lot. If you work for a hosting provider, you do it maybe every day. All right, so hopefully you are working or will work for an environment that gives you a lot of networking experience, where it's pure networking. The hosting providers are great for that. If you're on the network side, ISPs are great for that. A lot of places now, they're doing network administrators and network engineers. You're kind of half and half with networking and servers. That may not be the best area for you if you're planning to go heavy duty Cisco. You want to get into an area where you're doing VLANs every day or OSPF every single day. Okay, so we got this area 1, area 0, area 2 all set up just great. Now we're going to finish things up with redistribution. So redistribution is something that you really shouldn't do kind of like as practice. It's only your last resort, because really if you have a company that's OSPF and you buy another company with Eigrp, you should really migrate everything to one protocol eventually. You really shouldn't have both as separate protocols, but there's politics involved and sometimes you have to redistribute. So in this case right here, we're going to pretend that these loopbacks over here, or one of the loopbacks, let's make it simple. Let's do one. Let's not kill ourselves tonight. So this 200.111, we're going to take it out of OSPF. That means we're going to have to change some of our network statements on router 7. We're going to put loopback 200 into Eigrp. Right? We're going to put it into Eigrp, and then we're going to chuck Eigrp into OSPF and OSPF into Eigrp. All right. So let's see if we can do this. First of all, we have to go on to R7. And if we show run pipe B, so begin with router OSPF, we'll see that we have a Hail Mary network statement in there. So we can't have this because it's going to grab the loopback out of there. So we're going to have to undo that guy. So router OSPF 1, no network, all zeros, area 2. So we're just canceling that out. And you can see our debugs go crazy. We're just deleting all this stuff. So we only want to put the interface between 6 and 7 into OSPF. So let's do this way. Let's do show IP interface brief. And so the link between 6 and 7 is 10.10.67. It's fast 00. You could do it this way. You could look for it this way, or you could do show CDP neighbor. and that will tell you that R6 is going out fast 00. Either way is fine. So we'll go to the interface and just set that guy to OSPF area 2. And we'll get our routes coming back. So that's good. And if we go back to R2 and see, it blew out my eardrums. Okay, you got to fix that. Okay, if you go to R2 and ping 200.111, you can't ping it anymore, and that's because it's been taken out of OSPF. And does everyone understand what just happened? All we're doing is we redid the network statement. We threw just the link in between 6 and 7 into OSPF. So there. And by doing so, we've killed connectivity to loopback 200, because loopback 200 now is not part of anything. It's just connected to R7. Okay, now we're going to throw loopback 200 into Eigrp. And let's make sure we're on the right router, R7. So router Eigrp 100 is fine. No auto. That way it doesn't auto summarize. And then we're going to do a network of 200.111. And pretty sure I could just hit enter there. And we can show IP Eigrp interfaces. And we'll see that we have loopback 0 in there. So now what we want to do is we want to take Eigrp, chuck it into OSPF. And I'm going to start a debug on R2. So that's the router all the way on the left. So debug IP routing. That way I can see routing changes. So theoretically, if I throw Eigrp into OSPF on router 7 in about 10-20 seconds or so, I should see the corresponding route on R2. At least we would hope so. So R7 conf t. So go into OSPF. So we're taking Eigrp and chucking it into OSPF. And then we'll need to do the same thing by going into Eigrp, and we'll be chucking OSPF into Eigrp. So the command is redistribute, and if you do a question mark, you can redistribute pretty much anything. Connected, BGP, ODR, Jesus, static routes. Redistribute static, you'll probably do more common than most of the other stuff. So what are we redistributing? We're chucking Eigrp into OSPF. So you're going to put Eigrp in the AS number, which is 100. And for OSPF, we're going to use the word subnets. If we don't, then only the classful stuff gets popped in there, which for 200 is not 200.111. I don't think that would actually change anything. It's still /24. And we can just hit enter. Let's just wait a bit, see if anything pops up on R2. And yeah, that was about 10 seconds. And the terminal program inside of Linux Mint, it changes color at the top tab when you have extra text. So I know that something happened. So you see immediately 200.110/24 is in there. So why would this be used? Redistribution? Or you're talking about the terminal program? Why would we redistribute? Okay. Let's say Area 0, Area 1, and Area 2, that's all your company. You buy another company and you connect their routers off this link. That company is running Eigrp. Now what are your options here? Your options are, theoretically, how would you get connectivity to the other side? Uh, could you put, let's say on R7, like maybe do a default route, default information originate, and just slam all zeros route to your company, your side of the company? Would that work? So basically, tell all these guys 0, 0, 0, 0, right? So that might work, right? And then over here on this side, you do the same thing. It's kind of an ugly way of doing it, but you could do it. Your other option is you take all the Eigrp routes, chuck them this way, and on this guy, all the OSPF routes, and chuck them that way. Then what's going to happen is you're both going to see each other's routes, and you're able to get to the other side. So redistribution, you're generally with mergers, different departments. You're also going to see it with MPLS, because with MPLS, you're the ISP, and you're redistributing a whole bunch of crap into BGP. And then on the customer side, well, not the customer side, but on the edge side, towards the customer, you're going to be redistributing BGP back into RIP or BGP back into OSPF, because the customer only wants to do OSPF. So going back to our stuff, in R2, we see that we now have a route to 200.11.0/24. Now if I try to ping it, we do have a ping, and that's because we've cheated a little bit, because it's directly connected on that loopback. But if there were other links, if we pretended that loopback was connected to other stuff, we wouldn't be able to ping, because we have to put OSPF into Eigrp. So let's go back to R7. We have to do what's called mutual redistribution. Man, there's a lot of noise out there. Okay, let's go into Eigrp router Eigrp 100. And to throw OSPF in, it's OSPF, and it's process ID 1. And we have to give it a metric. And you're supposed to type in the bandwidth and delay and all this stuff, but usually what you can do is you can get away with just typing in all ones across and hit enter. So 5 ones, 1, 1, 1, 1. And what you're doing there is you're telling the K values to be all 1. Most of the time, not a big deal what metric you type in there. Right. And that gets OSPF routes into Eigrp, and then if you had other hosts connected to Eigrp, they'd be able to ping all the way back into OSPF. Okay, on that redistribute command, it's going to be metric 1 space 1 space 1. So spaces in between those ones. Because if you leave it at 5 ones there, that's going to be one hell of a delay. All right. So that covers pretty much everything that will get you past CCNA for OSPF. We did multi-area, we did virtual links, we did redistribution. In the previous classes, we looked at LSAs. We're going to just do a couple show commands, some troubleshooting things, and then we'll wrap it up. So learning what the show commands contain and how to use them and how to parse them out, very important, because Cisco's putting more troubleshooting into all of your tests. They're making them much harder because people are brain dumping them, and troubleshooting stuff they can change up a lot quicker. So first order business, show IP protocols. Sometimes my go-to thing just to see if OSPF is up. This will tell you if you have any filters set. Filters are what you can do in, hopefully you don't get them in CCNA, but in CCNP and CCIE, you want to be able to filter certain routes from getting to other areas. So you basically say, I'm going to tell you everything except I don't want you to get to this loop back. And this will tell you if there's a filter list set up. For those of you guys going for CCIE, in the troubleshooting section, you might see that you can't get to somewhere. This is just a quick thing. Am I filtering it out? Then you've got router ID. That's your router ID. Maximum paths, 4 maximum paths. Interfaces that you have in area 2. And the different routers that you're getting information from. So we're getting information from router 6 and router 5. Right? Usually you're just going into show IP protocols just to see if you have OSPF up and running. John, what's up, man?
Hey, man. Long time to see.
Yep. You have your number?
No, I do not. That's what
Yeah. How was it?
rougher than expected. I'll give you a scoop after you're down there.
Okay.
Whenever sometime later on.
Okay. So John, if you guys didn't know, he took his lab last week, and he was studying like mad for the last 2-3 months, basically doing a mock lab every 2 days. He was nuts, and then he was joining our session, so he was crazy. So he was in my Narvik boot camp a couple months ago. Okay, show IP protocols, pretty simple stuff. Show IP OSPF neighbor. This is another very common thing. If you do show IP OSPF neighbor, you don't see anything, that's a clue that you mess something up. Right? You're not seeing anything in your routes, immediately do show IP OSPF neighbor. Another thing that I commonly do, probably more common than show IP OSPF neighbor, this is just a stupid check. Show IP OSPF interface brief, and this will show you if you have any interfaces in OSPF. If this is empty, that's also another clue. That means other routers in your area won't be able to see you. Okay, show IP OSPF, do a question mark, you'll see kind of all the stuff that is in there. Virtual links is good. Well, virtual links over here on R7, not going to do us very much because that virtual link is actually in area 1. So if we go back to R3, show IP OSPF virtual link, this should show us something because we actually have our virtual link in R3 going to R5. So it tells us that our virtual link is up. That's good. Do not age LSA allowed, so that's pretty good. It's telling us that don't kick them out if they reach a certain age. Transit area, we're going through FAST01. So that's good. We have hello and dead timers on that. And everything else is pretty much, we don't need to worry about anything. Show IP OSPF question mark. Database we know about, flood list we don't need to worry about. Interface. Now if we just show IP OSPF interface, this gives us detailed information. So if we go down here to FAST00, Network type is broadcast. That's because it's fast Ethernet. Only time you really need to worry about network types is, well, there's two times. The main thing that Cisco likes to test you on is on the loopbacks. They want you to change the network type to point-to-point. And that's because on loopbacks, the network type is a stub because it's a fake interface. So Cisco goes, well, there's nothing really connected to it, so it might as well be a /32. But Cisco does a lot of this pretend. Let's pretend that that loopback is actually still a /24. So if you change the network type, it will change the mask. And just to show you what that is, how that works, if you show IP route OSPF on router 2, show IP route OSPF pipe I O, we'll see one of these loopbacks. You'll see it as a 5.5.5.5 /24. We want to change this to a 5.5.5.0. So let's see if we can do that. Let's go over to R5, go into that loopback, interface loopback 0, and it's IP OSPF network point-to-point, right? And we do that. And if we go back to R2, wait a bit. Show IP route OSPF pipe IO. And let's see if this changed over to /24. Oh, actually, I don't think it's going to change over to /24. And the reason for that is going to be very simple. Yeah, if I show the running config of that loopback, yeah. I'm not going to change it to /24 because if you look at the IP address, what do I have it set up as? That's exactly right. I did all these loopbacks as /32s. I could fix that, not a problem. Change that IP address to 5555, 255, 255, 2550. All right, solve that problem. Go back to R2. I got some stuff happening. 5555 should have disappeared. Yeah, all fives disappeared, replaced with 5550. And the reason I see that now is because I have OSPF network point-to-point. Before it was called a stub network. It was only giving me a /32. So Jerry has a question. For DR selection, is this correct? Router ID, router priority, loopback IP address. Okay. Router ID generally will usually work, but there's something that goes even before router ID. You should always ask yourself, is another router on the link already the DR? If another router is already the DR on that link, then you won't be the DR. There's no preemption. But if two routers come up kind of at the same time within the 40 seconds, then it's the router ID. And priority is kind of interesting. You start playing around with the priority generally when you want to force whether you want to participate in the election or not. So priority of 0 means you don't participate at all. But yeah, priority comes into play. And yes, the loopback comes into play afterwards. But before all of that, it's going to be whether another router is already the DR on that link. Okay. All right, folks. Any questions before we wrap this up? This is going to be the last session for beginning OSPF. We've gone to 4 parts, and this pretty much covers the stuff for CCNA. We didn't cover authentication, but that's something, you could do a couple exercises and you got it.